You've done this before. You lie down, you stop moving, you finally rest. Your muscles relax, your breath slows, your body becomes still, or at least that's what it feels like. But let me make a bold, almost arrogant claim right from the start. Your body has never been still. Not once, not ever. Not while sleeping, not while meditating, not even after death. And here's the uncomfortable twist. The universe would have to be dead for you to truly stop moving. Why? Because stillness, true stillness, is not a biological problem. It's a physics problem. And the laws of physics, well, they're not on your side, so let me ask you something. Have you ever actually seen something completely motionless? Not look still, not close enough? I mean, absolutely frozen, no vibration, no heat, no jitter. Why not? Let's peel this illusion apart, layer by layer, starting from the deepest rules of reality. At your scale, the human scale, motion looks optional. You can stop walking, you can hold your breath, you can sit quietly, but physics doesn't care what things look like. Physics cares about what must happen, and at the atomic level, motion isn't a behavior, it's a requirement. Here's the core idea, stripped down to its bones. Anything with temperature is moving. And temperature isn't some abstract number on a thermometer. Temperature is motion. More precisely, it's the average kinetic energy, the restless jiggling of particles. Atoms vibrate, electrons buzz, molecules twist, collide, rebound. Even in a solid, especially in a solid, atoms are not sitting politely in place. They're more like kids forced to sit still in class. They stay roughly where they are, but they never stop squirming. And your body? It's warm, very warm, which means it's a festival of motion. Imagine a table covered with thousands of tiny balls. If the table is perfectly still, absolutely still, the balls might stop rolling. But now imagine the table is shaking. Just a little, not enough to see, but enough to keep every ball vibrating, colliding, never settling. That shaking, that's temperature. Your body isn't just on the table. Your body is the table, and the shaking never stops. So why does your body feel still? Because your brain evolved to care about macroscopic motion, big stuff, muscles contracting, limbs moving through space, objects changing position relative to each other. But atoms don't ask for your brain's permission. They obey statistical laws at the microscopic level. Motion is random. Direction cancels out. Vibrations average to zero from your perspective. It's like standing in a stadium where 50,000 people are jumping randomly. From above, the stadium looks stable, but zoom in, absolute chaos. Stillness, it turns out, is just motion averaged out. Now you might say, fine, motion depends on temperature. So what if we cool something down enough? Excellent question. Physics already tried that. There is a lowest possible temperature called absolute zero, 0 Kelvin, 273.1, 5 degrees Celsius. At this temperature, classical physics says, all motion should stop, atoms should freeze in place. Perfect stillness, the end of motion, except the universe refuses, quantum mechanics crashes the party. According to quantum physics, particles cannot have exactly zero motion. Why? Because of the Heisenberg uncertainty principle. It says, roughly, that you cannot perfectly know both where a particle is and how fast it's moving. If a particle had zero motion, its position would have to be perfectly defined. The universe doesn't allow that, so even at absolute zero, atoms still jiggle. This is called zero-point energy. Not optional, not removable, not negotiable. The universe has a built-in hum, a baseline vibration, a cosmic you can never fully stop. Think of an atom like a tightrope walker. If they stood perfectly still, they'd fall. Stability requires motion, tiny adjustments, constant corrections. Quantum particles are the same. They must move to exist. Absolute stillness isn't balance, it's collapse. Now someone always asks, what about when you die? Surely then motion stops. But biology is just organized physics. When life ends, chemical reactions slow, large-scale processes cease, conscious coordination disappears. But the atoms, they don't get the memo. They keep vibrating. They keep exchanging energy with the environment. They drift, rearrange, recombine. Death is not stillness. It's decoordination. The orchestra stops playing together, but the instruments keep humming. Life is like an orchestra. Motion doesn't begin at birth. What begins is synchronization. When you die, the conductor leaves, the musicians wander off, but the sound never fully disappears. Now let's talk about the real villain here. Entropy. The second law of thermodynamics. It says, left alone, systems move toward disorder, not because they were lazy, but because disorder is statistically overwhelming. There are more messy arrangements than neat ones. Your body is a miracle, not because it moves, but because it fights entropy. It pumps energy, maintains structure, exports disorder to the environment. The moment that fight ends, entropy wins. But even then, motion continues. Just not your kind of motion. Atoms don't care about time. Their equations mostly work forward and backward. But large systems, they have memory. They break, they decay, they age. This is why you never see shattered glass reassemble, heat flow from cold to hot. Dead bodies spontaneously animate, not because it's impossible, but because it's astronomically improbable. Motion doesn't stop. It just becomes unrecognizable. Now here's where this stops, being depressing, and becomes profound. You are not a static object in the universe. You are a temporary pattern of motion, a whirlpool, not a rock. The atoms in your body were inside stars, drifting through space, part of ancient oceans. They didn't begin with you. They won't end with you. What's rare isn't motion. What's rare is organization. And for a brief moment, that organization is you. Feynman loved this idea, that the universe isn't quiet. It's alive with activity, not purposeful, not emotional, but endlessly creative. And somehow, against all odds, it assembled something that can ask, am I moving? That's not trivial. That's astonishing. So does your body ever really stop moving? No, and that's the point. Stillness would mean the universe gave up. Motion is existence, vibration is survival, and life is motion that briefly learned how to remember itself. So the next time you lie still, feel the quiet hum beneath the silence. You are not at rest, you are participating in the oldest dance there is. Let me ask you this. If you are a temporary pattern in a moving universe, what kind of pattern do you want to be while it lasts? Tell me in the comments.